Assalamu alaikum. This is me here with more fun physics content. So here, I have an interest to look at basically when we talk about two frames, right? How we can connect the information as observed from the two reference frames and all that. So then I will look at what can be the possible conclusion from this discussion and all that. So let's get started here. Let's assume I have got here the frame S, okay, which is going to measure two events, namely the position and the time of a given object. And there is one more frame that's known as S prime frame, which also measures the two events, that's delta x prime and delta t prime for the same object, right? Now, let me just talk about here the frame S prime. It's moving with some velocity v. I can assume along the positive x direction. Okay, it is going to be measured uh, with respect to the frame S. Right now, let me just connect. I mean, this delta x, delta t, delta x prime, and delta t prime by the two equations. I will write here first of all. So delta x, it is some gamma times 1 plus delta x prime plus v delta t prime. Delta t is some gamma times delta t prime plus v upon c square and delta x prime, right? These are well known, what's called that the Lorentz transformation equations, right? These are known as the Lorentz transformation equations. Now, if I will say here the frame S prime is moving with the velocity v2 as observed by the frame S1, okay, right? And the object is moving with the velocity v1 as observed by the frame S1. The object's moving velocity v1 as observed by the frame S prime, but the frame is itself moving with the velocity v2 and it's observed by the frame S1. So from above transformation equations, what we can get here sets delta x is gamma delta x prime plus v2 delta t prime, and delta t is gamma delta t prime plus v2 by c square delta x prime. Okay, why this gamma, it's known as a Lorentz factor and its value is 1 upon square root of v square upon c square, where c, it is the speed of light. Okay, now if I can assume the velocity of the object, right, the same object whose velocity is measured by the frame S prime, that's v1. Now its velocity is observed by the frame S. I can say it is supposed to be v. So these delta x, delta t are the position and time coordinates for an object, right, in the frame S. So if I will divide these two, I mean the equations, I can number them first and second. So what I will get here, delta x upon delta t, gamma will go, it's delta x prime plus v2 delta t prime upon delta t prime plus v square upon c square delta x prime. Okay, now it is basically what the change in position upon the time interval, that you must know it is a speed, and this speed for a given object is observed in the frame S, right? Okay, so from here, if I will just suit my discussion, what I will get further, that means v is equal to here delta x prime plus v2 delta t prime upon delta t prime plus v2 upon c square delta x prime. Okay, if I will divide the equation and multiply the equation by delta t prime upon delta t prime, what I will get if I utilize this delta t prime here, delta x prime upon delta t prime, that's the velocity observed by the frame s prime for a given object. So we assume that that's v1 plus it is v2, and it will go here 1 delta t prime, that's 1 plus v2 upon c square delta x prime upon delta t prime, that's v1. Okay, and this equation is basically known as velocity addition formula. So what are the amazing consequences of this equation? If I will enclose it for a moment, see, this equation is basically the symmetric in v1 and v2. It is symmetric under v1 v2. You can write down v2 in place of uh, v1 and nothing will change here. So we can conclude this equation is symmetric in v1 and v2. Now if I can say under case number second that v1 v2, okay, both are less than c, both are less than c. Now v1 v2 are less than c, their product will be more or less for c. So I can drop the second term in the denominator, so v will be nearly equal to v1 plus v2, and this is a very famous classical result. Okay, now the third most case of this thing is, if I can assume from here v1 is equal to v2, that's equal to c, so v here that will be 2 times c upon 1 plus it is here c, that's c square, it should be 1, so v will be equal to c. So third conclusion is indeed very very important conclusion. Now I will state it here. Basically for all observers, right, doesn't matter whether they are at rest or in motion, so the speed of light is same for all observers, right? The third conclusion is indeed the very essential conclusion here. So the speed of light is same for all observers. You can check it from here after plugging the value of v1 is equal to v2. So by using this velocity additional formula, so we got what's called that the speed is going to be same for all reference frames and all that. Thank you.